Welcome students. Previously, lesson 1 in chapter 2, we were dealing with the introduction side of energy change in physical and chemical processes. We are done with the endothermic and exothermic reactions. We have drawn energy level diagrams for endothermic and exothermic reactions. Then lastly, we are dealing with enthalpy notation. So in lesson 2, we are dealing with bond breaking and bond formation in physical and chemical processes. So, the atoms in elements or compound are held together by a chemical bonds, and we are told for a reaction to occur between substances, the bond must be broken. A new bond formed as constituent atoms recombine to form new substance. For example, if you are dealing with a reaction like hydrogen gas reacting with chlorine gas, we are going to get the product as hydrogen chloride gas. But before you get this product, we are told the reactants, the bonds in the reactants are broken down. That means here we are having hydrogen bond plus chlorine bond. So they will be broken down and they recombine to form hydrogen chlorine bond, which were 2 moles. So we are told for reactions to occur between substances like the hydrogen gas and chlorine gas that we have taken right now, the bonds must be broken and the new bonds formed as constituent atoms recombine to form new substances. Okay, let's just try to have some definition like latent heat of fusion. What is latent heat of fusion? So if you know how to define only latent heat of fusion, that means you are able to define the rest. Okay, what is latent heat of fusion? Latent heat of fusion is the amount of heat energy required to convert a given amount of solid substance to a liquid at its melting points. Remember, metals melt, solids melts to form liquid, while liquids boils to form gases. Okay, what is latent heat of fusion? This is the amount of heat energy required to convert a given amount of solid substance to a liquid at its melting point. So what is molar heat of fusion? So molar heat of fusion will be the amount of heat energy required to convert 1 mole of solid substance to a liquid at its melting point. So it will be the same. Okay, so what is a molar heat of fusion? You only know latent heat of fusion, and you are going to say this is the amount of energy required to convert. Where you are saying a given amount, you say 1 mole of solid substance to a liquid at this melting point. So it will be the same. It will be okay. You have defined what molar heat of fusion is. Then next, let's go latent heat of vaporization. So this is the amount of heat energy required to convert a given amount of liquid substances, or you can say a given volume of liquid substances to a gas at its boiling points. So that means if you know how to define latent heat of fusion, you also know how to define latent heat of vaporization, because you are going to change only small side, that is to convert a given mass of solid, you put it liquid, to a liquid, you put it to a gas. At its melting point, you change it to a boiling point, So what is latent heat of vaporization? This is the amount of heat energy required to convert a given amount of solid substances to a gas at its boiling points. You can say like that. Lastly, we're having molar heat of vaporization. What is molar heat of vaporization? So if you know latent heat of vaporization, you know this one is very simple. You say this is the amount of heat energy required to convert. Instead of a given amount, you say to convert 1 mole of liquid substances to a gas at this boiling point. So the definition will be very cool like that. Okay, note, we are told bond breaking requires energy. So if it requires energy, hence it is an endothermic reaction, because endothermic reactions are reactions that absorb from heat energy from the surrounding, while bond formation releases energy, hence it is an exothermic reaction. Because exothermic reactions result to a release, or they give out heat energy to the surrounding. So if you want to get now the heat of a reaction, you can use the formula of which is bond breaking energy, that is BBE plus, which is positive, plus bond formation energy, that is BFE, which is negative. If you use that formula, that means you can get the heat of a reaction. Okay, so next we are having here bond breaking and bond formation calculations. We are going to start with example number 1. So in this lesson we're having example number 1. In our next lesson we are going to have the other examples for this bond breaking and bond formation calculations. So example 1, we are told to use the bond energies, the following bond energies, to determine whether the reaction below is exothermic or endothermic reaction. Okay, we are having that reaction of hydrogen gas reacting with chlorine gas to form 2 of hydrogen chloride gas. So we have the bonds as hydrogen bond, and the energy is positive 436 kilojoules per mole. We're having chlorine bond, which is positive 244 kilojoules per mole, and we're having hydrogen and chlorine bond, which is having a bond energy of 432 kilojoules per mole. So if you are told determine whether the reaction below is exothermic or endothermic, first of all we are supposed to have the heat change. You have to get the heat change, and the formula of getting the heat of a reaction is bond breaking energy, which is positive, which is given positive, and bond formation energy by adding bond formation energy, which is negative. That's the formula. That's the time. If you get your positive sign, that means the reaction will be endothermic reaction. If you get a negative sign as your overall enthalpy change or heat of the reaction, you are going to have an exothermic reaction. Okay, let's start first of all writing this equation in open structured. Okay, let's have our bond breaking and bond formation. Okay, here we're having hydrogen gas. So hydrogen gas can be written hydrogen bond with another hydrogen bond. That's hydrogen bond. So we're going to have chlorine gas. We can write now chlorine to chlorine. It's single covalent bond in between them. So we're having arrow. The product here is hydrogen to chlorine bond. So this is a gas. So the valence there is 2. So we're going to put 2 there. So let's first of all have bond breaking energies. Bond breaking energy. So bond breaking will be on the reactant side. It has to be on the reactant side. This is bond breaking. So, and this is bond formation, because we are told bond breaking requires it's an endothermic reaction. So if it's an endothermic reaction, it absorbs heat energy for these bonds to be broken down, so that new bonds are formed on the product side. Hence it releases heat energy, making now bond formation to be an exothermic reaction. Okay, so we are having hydrogen to hydrogen bond with bond energy of 436. We add plus that side of chlorine to chlorine, which is 244. Okay, so if I add these two, I'm going to get positive 680. So I'm going to get 680 kilojoules per mole. This is the side of bond breaking energies. Bond breaking energy. Okay, let's go the other side. On the product side, that is bond formation energy. Bond formation energy. In bond formation energy, we are having 2 of hydrogen chlorine gas. I mean hydrogen chlorine bond. So we're going to put 2 open bracket. What will be the value for hydrogen chloride? A hydrogen chlorine bond. Hydrogen chlorine bond is 432 positive. So when you multiply this, you are going to get 864. So multiply that, 864. Okay, let's now get the heat of a reaction. Okay, heat of reaction. Heat of reaction is given by bond breaking energy, that is bond breaking energy, plus bond formation energy. Remember, we are told bond breaking energy is positive because that's an endothermic reaction, and the sign for an endothermic reaction is positive. So here I'm having positive 680 plus. But we are told again, bond formation energy is an exothermic reaction, so it releases heat energy. Hence, it's given a negative sign. So we're having negative 864. So the net charge here, the net energy, we are going to get negative 184 kilojoules per mole. Negative 184 kilojoules per mole. So that will be the heat of a reaction. If it is the heat of the reaction, let's just conclude, because we are told, if we go back to the question, you are told use the following bond energies to determine whether the reaction below is exothermic or endothermic. So we have to use now the heat of a reaction to state whether that reaction is exothermic or endothermic by just checking the sign that we have there on that heat of a reaction energy. Okay, so we are having here negative. That means this reaction is exothermic. It is exothermic. Yeah, exothermic. And the reason being, this is due to the negative enthalpy change. So you can say this is because of the negative, enthalpy change. Because of the negative enthalpy change. That is it. So in our next class, inshallah, we are going to go to example 2 of this bond breaking and bond formation calculations. Thank you.